Hello and welcome to our YouTube channel, Celestial Space Facts. Today in this video, we will got to know about dark matter. What is dark matter? Dark matter is the mysterious stuff that fills the universe, but no one has ever seen. Over 80% of all matter in the universe is made up of material scientists have never seen. It's called dark matter, and we only assume it exists because without it, the behavior of stars, planets, and galaxy simply wouldn't make sense. Here is what we know about it and what we think we know. What is the dark matter and why is it invisible? Dark matter is completely invisible. It emits no light or energy and thus cannot be detected by conventional sensors and detectors. The key to its exclusive nature must lie in its composition, scientists think. Visible matter, also called baryonic matter, consists of baryons, an overarching name for subatomic particles such as protons, neutrons, and electrons. Scientists only speculate what dark matter is made up of. It could be composed of baryons, but it could also be non-baryonic, that means consisting of different type of particles. Most scientists think that dark matter is composed of non-baryonic matter. The lead candidate, WIMIPC, as weakly interacting massive particles, are believed to have 10 to 100 times the mass of a proton, but their weak interactions with normal matter make them difficult to detect. Neutrinos, massive hypothetical particles heavier and slower than neutrons, are the forecast candidate, though they have yet to be spotted. Stellar neutrons are another candidate. Neutrons are the particles that don't make up regular matter. A river of neutrons streams from the sun, but because they are rarely interact with normal matter, they pass through Earth and its inhabitants. There are three unknown types of neutrons. A fourth, the stellar neutron, is proposed as the dark matter candidate. The stellar neutron would only interact with regular matter through gravity. One of the outstanding questions is whether there is a pattern to the fractions that go into each neutrino species. An associate professor of physics and astronomy at Michigan State University and a collaborator on the iceberg in Antarctica told Space.in that the smaller neutral axion and the uncharged photons, both theoretical particles, are also potential placeholders for dark matter. There is also such a thing as antimatter, which is not the same as dark matter. Antimatter consists of particles that are essentially the same as visible matter particles, but with the opposite electrical charges. These particles are called antiprotons and positrons. When antiparticle meet particles, an explosion ensures that leads to the two types of matter cancelling each other out. Because we live in the universe made of matter, it is obviously that there is not such much antimatter around, otherwise, there would be nothing left. Unlike dark matters, physicists can actually manufacture antimatter in their laboratories. Why do we think dark matter exists? But if we cannot see dark matter, how do we know it exists? The answer is gravity. the force exerted by the objects made of matter that is proportional to their mass. Since 1920, astronomers have hypothesized that the universe must contain more matter than we can see because gravitational forces that seem to be at play in universe simply appear stronger than the visible matter alone would account for. Motions of stars tell you how the matter there is, a researcher at Yale University said in a statement. They don't care what form the matter is, they just tell you that it's there. Astronomers examining spiral galaxies in 1970s expected to see material in the center moving faster than at the outer edges. Instead, they found the stars in both locations traveled at the same velocity, indicating the galaxies contained more mass than could be seen. Studies of gas within elliptical galaxies also indicated a need for more mass than found in the visible objects. Clusters of galaxies would fly apart if only mass they contained was the mass visible to the conventional astronomical measurement. Different galaxies seem to contain different amounts of dark matter. In 2016, a team led by Van Dockum found a galaxy called Dragon 44, which seems to be composed almost entirely of dark matter. On the other hand, since 2018, astronomers have found several galaxies that seems to lack dark matter together. The force of gravity doesn't allow only affect the orbits of stars in galaxies but also the trajectory of light. Famous physicist Albert Einstein showed in early 20th century that massive objects in the universe bend and distort light due to the force of their gravity. The phenomenon is called gravitational lensing. By studying how light is distorted by galaxy clusters, astronomers have been able to create a map of dark matter in the universe. A vast majority of astronomical community today accept that dark matter exists. Several